Hey class, Mr. Blackwell here. Again, hopefully you're doing good. Just wanted to keep in touch with you. I want you to recognize that we're getting near the end of chapter 8 here, so you want to start preparing, if you haven't done so already, for a chapter 8 test next week. So keep that in mind. If something you want to be preparing for is that chapter 8 test next week. Today we'll be looking over lesson 8.2.3, how can I use exponential functions. This partly entails with solving a system of exponential functions graphically, and partly what you will be doing, kind of objective from this for this lesson, is to write and graphically solve a system of exponential function in the context of investigating car prices. So we'll be looking at a few different car prices and seeing what they do over time and evaluating those prices on, kind of what would be the best car to get. Really only one problem we want to focus in on today, and that's problem 8.1.15. If you're really struggling with 1.15, you can do problem 8.1.16, and that'll kind of walk you through step by step. But I also think that if you really ask yourself what is your task and also go through the discussion points of 1.15, you should be fine. But if you're unsure of really what those discussion points or what your task is in 1.15, go to 1.16 and try to use 1.16 to help you solve it, the scenario that we've been presented. Couple things to keep in mind as we're going to be looking at solving systems of equations. We've looked at some different methods. When we've looked at linear equations, we've looked at elimination method, equal values method, and substitution method. And these were all three different methods to solve systems of equations if we had two linear equations. Now what we're looking at is if we have a system of equations that is in exponential form, how can we solve for these? And once again, it can be very much the same kind of way of solving those systems of equations. The one main difference I would say is oftentimes with the linear models, we're using adding or subtraction to help us to solve those. They're one of the first steps. But with exponential models, one of the first steps we oftentimes will do, we'll divide the two equations together, because that division oftentimes will help eliminate A, which then just gives us the parameter B that we are trying to solve for. So, couple key words that this lesson introduces is depreciation, or a decrease in value, possibly because of normal wear and tear, age, decay, or decrease in price. And there's also appreciation, or an increase in value. Most cars are going to depreciate the second you drive out the lot with it. So the second you drive out that lot, you have lost money. You want to be able to turn around and sell the car for the same value, because it's losing money almost instantly. Very few cars will actually appreciate in value and gain, and you'd be able to sell them more than what you bought them for. So in this case, we are given three different cars. We're given the Concorde EX for $27,000, an Escalade that would have been $70,000 new if it was bought last year, and a 1967 Mustang for $18,150. And we're being told that the Concorde depreciates at 6% per year, and the Escalade will be worth $28,672 3 years from now. So I'll have you ask yourself, well, is that an appreciation or a depreciation? And our third color, the Mustang, we're given a small table for this year and the last couple of years on the cost of the car. And you can read over these questions more in depth. I'm just touching on the main things. But your task with this information is to investigate the value of each of these 3 vehicles over time. So your task, right, so there's 2 bullet points within this task, right? So we want to generate multiple representations of the values of each car over time. So you may want to ask yourselves, what does multiple representations mean again? What are we looking at when we see the words multiple representations? Hopefully you recognize, right? Multiple means more than one. You're not just doing one thing, you're doing multiple things. You're doing 2 or 3 things. And in our case, when we talk about multiple representations, we are talking about a situation, which we've been given in this case. And from the situation, can we create a table? Can we create a graph? Can we create an equation? Right? So these are things we want to be asking ourselves. And once we have created a multiple representation for each of these vehicles, right? For each of them, not just one, for our 3, you can decide which car Geraldine should buy and defend your choice in as many ways as you can. So try to tell us what car Geraldine should buy and why should Geraldine buy this car, right? That's kind of what you're trying to defend right now. But you want to have these multiple representations to back your reasoning and to back your explanation. Don't just say, well, she should buy this one car because it's a neat car. Defend it with numbers. Okay, not just opinions, defend it with numbers. So that will be the main thing you need to focus on with this lesson. You can feel welcome to make a graph that pitch our cars on the same graph. If you want to make 3 separate graphs, you can do that. Sometimes in a scenario like this, it's kind of nice to have everything graphed on the same set of axes because it's a little easier for comparison. But I'll leave that up to you on what you decide when you create your multiple representations. And I hope you have a great day, and tomorrow you'll have some time to work on homework.